So what's this all about? Polynomials, right? Again, polynomials have many terms. It can also have just one term. It really can still be a polynomial. You could have two terms and still be a polynomial. But we like saying many terms because a lot of times they come in lots of different forms. And we want to make sure we have whole number exponents. So they're curvy. They're curvy. So what we want to do is let's put this one on Desmos. Okay, you guys got your phone. Let's graph that one in Desmos. What did I do with my phone? I don't know. Here it is. So hopefully everybody knows how to use Desmos, right? Hoping so. Okay, if I go clear that. So I'm going to go y equals x squared subtract 4, okay? Did you guys get that answer? Everybody get that answer? Now we know this. We've been doing, that's a parabola, right? That's a parabola. But it's still a polynomial. Okay? So let's sketch that in. Let's go ahead and sketch that in. I'm going to go ahead and just put that on the graph. It looks something like this. And it says, what's the minimum value? Gosh, I love Desmos because you just tap on it. It's going to be 0, -4, right? I just tap on it. Desmos is awesome. So that's my minimum value.
Wait.
Yeah. So I just tapped on it. I'll put that in my calculator, into Desmos. Yeah, please stop me if you're a little confused, okay? I just tapped it. There's my minimum value. Let's look at the next one. Everybody okay? You want to look at the next one? So let's put the next one into our Desmos, okay? X cubed, and then subtract 9x. I'm going to squish it down. It's kind of big, isn't it? There we go. That looks really, I like this. Okay, sketch this graph. So I'm just going to put it, I'm going to go like this. Something like that, right? That's what I have on my calculator, right? What's our minimum maximum value? It's easy. Let's just tap it, right? That's got to be a maximum. So I've got a maximum at -1.7, comma 10.4. That's a maximum. And then to get the minimum, I just tap. I like phone, makes it easy, right? I get a positive 1.7 and a negative 10.4, okay? How am I doing? Thumbs up? No problem at all, okay? Now I'm going to add one more thing to this that I think will make a lot of sense. I really want to call this a local maximum, and I call it a local minimum because right here, this point right here is not the lowest point on the graph. You watching? There are points lower, aren't there? So we call it a local maximum because it's the bottom of a hill. This point right here, it's not the highest point on this graph because this graph keeps going up and up and up and up and up. But it's the top of a hill, okay? So the top of a hill, local max, bottom of a hill, local min. Pretty easy, right? Okay, you guys ready to turn the page? No problem at all, okay? Okay, let's sketch this graph. Come on. So let's sketch this graph. Now it looks like that, doesn't it? Okay, I'm just going to sketch that in. Something like this. Now this one does not, there's no max and no min. No local max, no min. So there's no, because I don't see the top of a hill, do you guys? So there's no local max and there's no local min. But the graph changes somewhere. You guys see where the graph changes?
0, 0.
Yeah, it changes 0. Good. So So we call this an inflection point. And I don't know if you've ever heard that on the news or business, they say they hit an inflection point. So think about this. You own a restaurant. You own a restaurant, okay? And business is slowing down, right? So all of a sudden you're like, ah, we gotta do something because business is slowing down, right? So you reinvest, or you hire Kevin to come in and run the restaurant, and then the restaurant takes off again, right? Okay? That's what they call an inflection point in business. All of a sudden you're starting to slow down, something changes. Of course, it could be the other, right? It could be a bad inflection point, right? Maybe you're doing great, and then you hire Mr. Davies to run your restaurant, and then it goes all downhill, right? So that's what we call an inflection point. It's not a max, it's not a min, it's an inflection point, okay? And Alonzo, you're right, it was at 0, 0, wasn't it? Okay, let's graph number 4. Okay, number 4 is an x to the 4th power. Subtract 3x squared. Subtract 5. Looks like a W, doesn't it? Okay, let's sketch that one in. It's going to look like this. So it's got 2 minimum values, doesn't it? I'm going to tap on it. One minimum value is at a negative 1.2 comma negative 7.3, and it's got another minimum value at 1.2 comma negative 7.3, and it has a maximum value. You can tap on that at 0, negative 5. So there's my local minimums and my local maximum. What do you think? This isn't too hard. You guys agree? Thumbs up? Okay. Now, last but not least, let's do number 5. Let's graph this, okay? X to the 5th power, subtract 3x to the 3rd power plus 2. Ooh, that's a weird looking graph, huh? That's a weird looking graph. Let's see if I can sketch it in. It's going to go like this. It's going to come down like that, make a turn. How's that? It's kind of what it looks like, okay? Now this has a max, a min, and an inflection point. Can you see it? Can you see the max, the min, and can you see the inflection point? Okay, let's find them. So all you gotta do is tap on them, right? So my max is at negative 1.34, or I'll just round negative 1.3. So max about negative 1.3 comma and about 4.9. It has an inflection point at 0.2. It has a minimum at a 1.3 and a negative 0.9. Okay, that's my local max, my local minimum, and that one's my inflection point. Okay, now I'm going to show you one last thing so you get the idea. So, they're curvy. You guys see that? And I don't know if you guys noticed, but the bigger the power, the more they curve. Did you see that? The bigger the power, so if I keep adding exponents, like x to the 5th, it gets more and more curvy, right? If I go to a plain old x squared, it's just got one bump, right? X cubed, look at that. See the difference? If I add an exponent, it curves more. X to the fourth curves even more, and then x to the fifth curves even more. These are polynomials. They all do this, all right? Okay, so let's see if we can just work on some homework, and I want to talk to you also about possibly another project, okay?